Today we're going to talk about methods of counting using the fundamental counting principle. And in order to use the fundamental counting principle, basically you draw lines for each stage of the problem. On each line, you write the number of choices for that stage, and then you multiply. Let's take a look at some problems. You'll definitely need a calculator when you're doing this. Okay, menu lists 7 beverages, 5 appetizers, 10 entrees, and 4 desserts. How many different dinners can you create if you have a beverage, appetizer, entree, and dessert? And then we'll ask a follow-up question afterwards. So, we're choosing a beverage, appetizer, entree, and dessert. That would be 4 lines. Let's say the first line is my beverages. I have 7 choices for beverage, 5 choices for my appetizer, 10 choices for my entree, and 4 choices for dessert. And I will multiply those because I could have any one of the 7 beverages with any one of the 5 appetizers. That would be 35 combinations right there. Then I could have any one of those 35 with any one of the 10 entrees. So now we're at 350. And I could have any one of those 350 with any one of the 4 desserts. So 350 times 4, 1,400. So meals. Now it says, what if you include not having dessert as an option? So you're too full. The waitress comes by and says, and what would you like for dessert? Okay. We're still going to have 4 stages to the problem, 7 beverages, 5 appetizers, 10 entrees, and 5 dessert options. The 4 actual desserts, let's say a sundae, a piece of cake, a piece of pie, churros, or no dessert. So no dessert now counts as the 5th option. So now we're going to take our 350 and multiply it by 5. So we have 1,750. Okay, let's try another one. Oops. You run an embroidery shop. You want to pre-program your machine for every possible 3-letter monogram. How many different 3-letter monograms are possible? So it's a 3-letter monogram. How many possibilities are there for the first letter in that monogram? Well, there are 26 letters in the English alphabet, so 26. It's possible that the second letter in the monogram, which is usually your last initial, could be the same as your first initial. So we still have 26 choices for the middle letter in our monogram. And the third letter in our monogram, which is usually your middle initial, it could be also 26. So we're going to multiply these things. Or I could just do 26 to the 3rd power to make it shorter in my calculator. So 17,576. Monograms. Okay. You have not prepared for a 5-question true-false test. You will have to guess at every question. How many different ways are there to answer the 5 questions? Okay. Well, it's a 5-question test. So there are really 5 stages to this test. If at the first question it could be true or false and you have no idea and you're just going to guess, then you have 2 choices. Second one is also a true-false question. True, false, true or false, True or false? So we would have 2 to the 5th, 4, 8, 16, 32. 32 ways to answer the test. Okay. You have not prepared for a 5-question matching test. You will have to guess at every question. How many different ways are there to answer the 5 questions? Again, there are 5 stages, right? 5 questions. But in a matching test, usually there are 5 questions and 5 answers, unless it's something strange that the teacher is doing. But let's assume it's a standard matching. So for the first question, any one of those 5 answers might be the answer. And if you have no idea, you're just going to randomly pick one of them. But the benefit of a matching is once an answer has been used, it doesn't get used again. So for your second question, you have only 4 choices. And for your third question, there are only 3 and 2. And hopefully you left the hardest one for last. Although if you don't know any of them, it doesn't really matter. But it usually, by process of elimination, that's the one. So I could multiply this out, or I could just do 5 factorial on my calculator, which is 120 ways. 10 people are lined up for a race. In how many different ways can they all finish the race? And then we'll ask a follow-up question. So, 10 people lined up for a race. How many ways can they all finish the race? Well, once the gun starts and the people start running, any one of them could cross the finish line first. But then once they've crossed the finish line, there are only 9 people left who could come in second, 8 people left who could come in third, 7, 6, 5, 4, 3, 2, and the position nobody wants to be in, the one person who's definitely going to be last. I'm probably not going to type it into my calculator that way. I'm going to type it in as 10 factorial. So let's do 10, and then math. It's under probability. Number 4. 10 factorial is 3,268,800 ways. 3,628,800 ways. I'm not going to try and remember that. Okay, follow-up question. What if we only care about first, second, and third place? Which is often true in a race. We only care about first, second, and third place. Gun sounds, any one of those 10 could finish the race first. Any one of the remaining 9 could finish the race second. Any one of the remaining 8 could finish the race third. And I don't care about the rest. So this is a little easier to do. This is 720 ways. Okay, how many ways can a class with 5 boys and 7 girls line up for recess? Well, first of all, we'd have to figure out how many people are in the class. 5 boys, 7 girls, that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Doesn't matter how they line up. Any one of the 12 could be first, and then 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Which I would use 12 factorial in my calculator for sure. What if the girls get to line up first? Well, there's still 12 kids in the class, but the girls are going to go first. So there are only 7 people who could be first in line because there are 7 girls. 6, 5, 4, 3, 2, 1. Now the girls are in line, and now the boys get to line up. So there are 5, 4, 3, 2, 1. So based on the way this looks, I would type this into my calculator as 7 factorial multiplied by 5 factorial. And it's going to be significantly less than our 12 factorial. 12 factorial as opposed to 7 factorial times 5 So significantly fewer ways. There are only 604,800 ways for the girls to be first and all the boys to be last, as opposed to hundreds, thousands, 479 million ways for all of them to line up in whatever order they end up lining up in. Okay, last question. Imagine a roller coaster that has two seats in the front, two seats in the middle, and two seats in the back. Great, I can see it now. Little wheels on there. Okay, 6 friends are going to ride together, and how many ways can they be seated? Great. Any one of the 6 could be here, 5, 4, 3, 2. I'm just writing those numbers in randomly. But in a sense, the first question I'm going to do is just 6 factorial, which is 720. What if only 3 are willing to sit in the front? Okay, so here are my 6 friends standing out here. Only 3 of them are willing to sit in the front. So sitting in this front seat could be any one of those 3. And then any one of the remaining 2. Now, the third guy who was willing to sit in the front, sorry, he just goes back into the general population because there isn't a seat for him in the front. So 4 are still left to sit, 3, 2, and 1. So this is going to be 3 times 2, 6, times 4 times 3 times 2 times 1, which would be 24. So 6 times 24, let's see, since 4 is 24, the 2, 144. So fewer than if everybody just sits randomly. Okay, so counting is a matter of seeing the problem, seeing the stages of the problem, and then identifying your choices. Good luck.